Okay, everyone, yeah, let's start with 439. We have 6 expressions to factor, and it says to factor them completely. If it's not factorable, explain why not. So we're going to be doing a lot of area diamond, and if you need a summary of area diamond, it is in the math notes for this lesson. So you should have your ebook open in a different tab and be looking at, and I need to do a better job of reminding you what lesson it is. It's 4.1.4. So starting with 439. Let's draw an area model. And the lesson that we did Monday or Tuesday is to see if we have any common factors. Well, there are no common factors in these terms, so we can just, this is kind of just a review of area diamond. Okay, remember that this product is going to be the same as this product. And that's why we use the diamond, because we are splitting these X tiles up. If we were building this with tiles, we would have 2 X squared tiles here and 5 red negative unit tiles here and 3 X tiles, and we would be trying to build a rectangle. And we notice that this product is the same as this product. Well, what is this product? Negative 10x squared, but we know it has to add up to 3x. You're only going to have 3x terms. Well, what can you multiply to get negative 10? But when you add it, you get 3. 5 and 2, right? So 5x and 2x is going to give us negative 10x squared. And those are our terms, but we need to make one of these negative because we're getting a negative 10 when we multiply them, but when we add, we're getting positive 3. So that means that the 2 needs to be negative. When I add these two together, I get positive 3. When I multiply them, I get negative 10. So it doesn't matter where the 5x goes or where the negative 2x goes, but that's how you would split this up if you were building a rectangle. So now we just get the length and the width. We know that 2x times x is going to give us 2x squared. Where that 2x goes matters. I cannot put 2x here because 2x is not a factor of 5x. 2x has to go here. So 2x times x is 2x squared. And then from there, 2x times what is negative 2x? Negative 1. X times what is 5x? Positive 5. So then my length and width, my area as a product would be 2x plus 5. And then x minus 1. So this is the sum. The area is the sum. This is the area is the product. You also have a product and a sum in your diamond. This is the product. Usually I put the product on top and the sum on the bottom. Okay, part B. Hope you're enjoying this holiday music in the background. Okay. So remember your x squared term. If you were building this and making a rectangle, there's usually multiple ways of doing that. But in order for this to work, we have to have the x squared term and the constant term in opposite corners. And we know that this product is the same as this product. This product is negative 6x squared, but I only have one negative x tile to split up. Sure, this would be physically possible with tiles, but perhaps it is. So what can we multiply and get negative 6, but when we add it, we get negative 1. So it's got to be 3x and 2x. When we multiply, we get negative 6, but when we add, we get negative 1. That means that 3 has to be negative, because negative 3 plus 2 is negative 1. Negative 3 times 2 is negative 6. So those are our missing terms. So if we were using tiles, we would actually use red tiles, 3 red x tiles here, 2 positive x tiles here. When you combine them, you would get 1 red x tile left over if you combine them and simplify. Okay, x times x is x squared, x times 2 is 2x, and x times -3 is -3x. So then my product, my length and width, would be x minus 3 and x plus 2. Okay, part C is 3x squared plus 13x plus 4. Still no common factors. So let's just do our area diamond. 3x squared and 4 are in opposite corners. This product is going to be the same as this product. So this is going to be 12x squared, and these have to add up to 13x. I only have 13x tiles to split up. So I'm looking for factors of 12x squared that add up to 13x. That's going to be 12x and 1x. I don't have to write the 1 right there. So then 12x and x are my missing terms. And then I'm going to find factors of 3x squared, and I'm going to be careful where I put that 3x because I can't put it right here. 3x is not a factor of x, but it is a factor of these two terms. So 3x has to go on the bottom and x has to go on the side. X times 1 is x, and 3x times 4 is 12x. So my length and width would be x plus 4 and 3x plus 1. Okay, had to get a little cough drop there. Look at part D. Okay, 2x squared and 7 in opposite corners. So 14x squared is the product of these two, which means it's going to be the product of these, but it's going to, the sum of those two sections is going to be positive 5x. Well, the only factors of 14 that would add up to 5 would be 7 and 2, but this is a positive 14. So we're not going to have 1 negative, 1 positive. And 14 and 1, that's not going to work. So actually, D is not factorable. And that's why we have other methods, which we will learn moving forward. I see on part E that we have a common factor. All of these terms are divisible by 7. So let's factor that out. So 7 times what is 7x squared? X squared. 7 times what is negative 7x? Negative x. And 7 times what is negative 42? Negative 6. And then this is the same as part B, which we already factored. So we know it factors into x minus 3 times x plus 2. So this is going to factor into 7 times x minus 3 times x plus 2. So that 7, you need to remember that that's part of the answer. Don't leave it over here. Bring it over. It's part of your final answer. Okay, I think I see another expression with a common factor. What are all of these divisible by? Well, they're all even numbers, so they're all divisible by 2. The greatest common factor for 6, 26, and 8 is 2. So let's factor out that 2. 2 times 3x squared is 6x squared. 2 times 13x is 26x, and 2 times 4 is 8. And then 3x squared plus 13x plus 4 is part C. So we know it factors into x plus 4 times 3x plus 1. So that means this final answer is 2 times x plus 4 times 3x plus 1. Okay. How'd you make out during the snowstorm? Hope you stayed nice and warm, had a little hot chocolate, had a little fun playing in the snow. Okay, for 441, it says that these two polygons are similar, and I am going to ask you to draw these because it's going to tell us to find x, but it's also going to tell us to find the area of each polygon, and I think it would be good to have a diagram. So take a minute and sketch these. Oh, I skipped 440 because, well, you're probably not too upset about that, but it's just not something that I think we need to worry about too much. Okay, we know that's the symbol for inches, hopefully. If not, now you know. Don't worry about this being perfect. So we know that they're similar. It tells us that they're similar. Sometimes it's easy to do this without a proportion. In this case, I think we should use a proportion, or you could do the scale factor. I know some people like doing that. So 10 corresponds to x. So I'm going to say, first of all, 4 corresponds to 10. So 4 is to 10 as 10 is to x. Whatever I do to 4 to get 10, and we're not adding, we are never adding when we're looking at similar figures. We're multiplying by something because this is a dilation of this one. So whatever I do to 4 to get 10, I'm going to do the same process to 10 to get x. Cross multiply, that's going to give me 100 equals 4x. So x equals 25. Okay, and let's get the area of each shape. Let's divide it up into a rectangle and a triangle. The area of this rectangle would be the base times the height. So 10 times 4 is 40 square inches. The area of this triangle would be the base times the height divided by 2. If this is 6 and this entire length is 10, then this must be 4. If this entire length is 12 and this is 4, now I know this doesn't look right, but this is 4, that means this must be 8, because 8 plus 4 would give me 12. 6 plus 4 would give me 10. So this triangle would be 4 times 8 divided by 2. So my entire area would be, let's see, 4 times 8, 32, divided by 2. This triangle is 16 square inches. The rectangle is 40 square inches. So the area of the smaller shape is 56. 40 plus 16, 56 square inches. Same process over here. We know 10 times 25, so 250. And then this entire length is 25. So if this is 15, 15 plus what is 25? This must be 10. This entire length is 30. This is 10. So 10 plus what is 30? This must be 20. So this triangle must be 10 times 20 divided by 2. So that's going to be 200. Divided by 2 would be 100. So the area of the entire shape would be 250 plus 100, 350 square inches. Okay, the next one, I think I'll pause the video and sketch. Well, maybe I'll just keep the video running. Shouldn't take too long. Okay, it says to decide if the triangles are similar, and then if they are similar, use properties of similarity to solve for x. If they're not similar, explain why not. There is a problem exactly like these on the test, the upcoming test. So I am going to try and find a way to squeeze in some review of this before we take that test, which it's looking like it will be in January. But make sure that you are not just going through the motions on this, that you're really trying to understand it, because I have a feeling the 3 questions on the next test that are involving similarity are going to be worth a bunch of points. They always seem to do that. Okay, so I'm going to draw the triangles separately. And then I'm going to use my pencil. Oh, wait. Okay. So let me do this first. So the parents being cut by 2 transversals. So it's cut by a transversal here, and it's cut by a transversal here. These 4 angles match these 4 angles. So this angle is the same as this angle. And then same thing over here. These 4 angles match these 4 angles. So then this angle is the same as this angle. And if you've got, and you actually have, this is overlapping, that's shared by both triangles. So you got all the angles the same. You really only need to know that for sure that 2 angles are the same to know that 2 triangles are similar. So the triangles are similar by angle, angle. Let's draw the large triangle over here. Oh wait, that is not the same angle. Let's make it look a little bit better. There we go. Okay, so we know that this length is going to be 13. And then this side, the long side of that larger triangle, is going to be 13 plus x. There's a lot of 13s in this problem. Okay, so we know that they're similar, and we know that these 2 sides correspond, these 2 sides correspond, because this angle matches this angle matches this angle, is congruent to this angle, and then these 2 angles are congruent here. So these 2 sides, this is an enlargement of 8, this is an enlargement of 13, and so I'm just going to set up a proportion because I don't know off the top of my head what I can multiply 8 by to get 13. So I'm going to say 8 is to 13 as 13 is to 13 plus x. This is the small triangle on the top. This is the big triangle on the bottom. I can't switch this around. If I decide to put 8 on the top and 13 on the bottom, this 13, so I'm doing small triangle on top and then large triangle on the bottom, I have to stick with that going across. I can't just flip around. Okay, so that's cross multiply. 13 times 13 is 169, and then 8 times 13 plus x is going to give me, 8 times 13 would be 80 plus 24 is 104 plus 8x equals 169. Subtract 104 from each side. That's going to give me 65 equals 8x. Divide both sides by 8. That's going to be 8 goes into 65 8 times with 1 left over. So 8 1/8, or 8.125 as a decimal. Okay, part B, you've got parallel lines in this picture, but you only have them being cut by 1 transversal. So you know that these 2 angles are equal, but you don't know anything else. And because this angle is not, well, we wouldn't even be able to use SAS because we don't know this measure here. So actually for part B, there's not enough info. Okay, part C, you've seen this before. This is like the swamp problem that 90% of you missed on that interim test, and it was worth a lot of points. These two lines are parallel and they are being cut by two transversals. You've got vertical angles that are congruent. You've got a pair of angles here. These four angles match these four angles. So this angle is the same as this angle. And then these four angles match these four angles, but we've got two angles already. That means we know the triangles must be similar. So let's sketch those triangles. You could just sketch the original. Okay, so here's our parallel lines, here's our vertical angles. If I extend these four angles here match these four angles here. So I know these two angles are the same, so they're similar by angle. So let's see, we've got X, 8, 6, 4, and 8. So we do need to be careful if we're setting up a proportion that we match corresponding sides. That's why you're paying attention to which angles are the same. You're not just guessing on that. In fact, it might help to put that third angle in there so we know what sides correspond. So you can tell that X and 8 correspond. They're in between the same pair of corresponding angles. But if you saw this on the test and you were like really not sure which sides go together, you could just take some tracing paper and trace one of your triangles, and then, okay, I'm gonna rotate this, and they're not gonna, the angles will match, but the sides are not going to match because they are similar. But that could help you with knowing what sides correspond. So X corresponds to 8, so X is to 8 as, X is to 8 as 8 is to what? 8 corresponds to 6. 8 corresponds to 6. So X is to 8 as 8 corresponds to 6. Cross multiply, that's going to give you 64 equals 6x. 64 divided by 6 would be 10 and 4 over 6, which is 10.6 repeated. Okay, 443, we've got some combinations. Joan and Jim are planning a dinner menu, including a main dish and dessert. They have 4 main dish choices: steak, vegetable cheese casserole, turkey burgers, and vegetarian lasagna, and 3 dessert choices: chocolate brownies, strawberry ice cream, and chocolate chip cookies. Joan and Jim would like to know how many different dinner menus they have to choose from and how many different menus are there. So I'm going to use an area model. I'm kind of a fan of the area model, but if you prefer to do a tree diagram, that is fine. Are you hungry reading about all of that good food? Did you eat a good dinner on Thanksgiving? Okay, so you probably guessed that there's 12 combinations, but let's just go ahead and sketch it out. Steak, vegetable cheese casserole, turkey burgers, and vegetarian lasagna. Okay. And then there are 3 dessert choices: chocolate chip brownies and strawberry ice cream and chocolate chip cookies. So what would you choose if these were your options? Well, I would choose the vegetarian options. Probably vegetarian lasagna and chocolate chip brownies. That sounds really good, in case you were wondering. Okay, so we have 12 combinations. So part A, we got 12 combinations. Part B, assume the main dish choice and the dessert choice are both chosen randomly. Are all the menus equally likely? Yes, there's no reason that you would have one of these choices be more likely than the other. So B, all equally likely. And then part C, what's the probability they pick a menu without meat? What's the probability they pick a menu with chocolate? So part C, probability of getting a vegetarian meal. There are 1, 2, 3, 4, 5, 6 vegetarian options. So that's 6 out of 12, which reduces to 1/2. And then part D, the probability of picking a menu with chocolate. Okay, well, you got chocolate chip brownies. You got all 4 of these have chocolate chip brownies. And then all 4 of these have chocolate chip cookies. So that's 8 out of 12, which reduces to 2/3. Okay, for 444, complete a table for the function y equals x squared plus 2. Use negative, positive, and 0 values for x. Then graph it, label the axes, and include the scale. So you will need half a sheet of graph paper for this problem. Okay, let's do our table beginning with -3, and let's just do a few values to the left and right of 0. I happen to know what this looks like, so that's why I'm picking these. If you didn't know, you might start with 0, and that's okay. But what you're going to see, this is y equals x squared plus 2. If I plug in 0 into this, so f of 0, I would get 0 squared plus 2. So that would be 0 plus 2, which would be 2. If I plug in 1 into x squared plus 2, I would get 1 squared plus 2. 1 squared is 1, plus 2 is 3. If I plug in -1, -1 squared is not the same. This is not the same as this. So it's -1 squared plus 2. -1 times -1 is +1, and +1 plus 2 is 3. If I had not put the parentheses, I would wind up with -1, because order of operations would tell me to do the exponents before multiplication, and this is an exponent of 2, so I would square 1 and take the opposite of it. It'll give me -1 plus 2. So be careful. That's the most common mistake people make when doing something like this, where you're solving for the output in a quadratic. Okay, let's do 2 and -2. F of 2 is 2 squared plus 2. So that's going to be 4 plus 2, which is 6. Guess what? F of -2 is also going to be the same, because if I take -2 and square it, I get the same thing as when I take +2 and square it. So that's going to be still +4 plus 2, which is 6. Okay, and then are you noticing a pattern here? Let's do f of 3 and f of -3. F of 3 would be 3 squared plus 2, which would be 9 plus 2, which would be 11. Same thing for -3 squared plus 2. That's also going to be 11. Are you noticing some symmetry here? That is a nice feature of quadratics. Once you get the hang of these, you will start to see some nice patterns, and hopefully the pieces of the puzzle will just fall right into place, because quadratics are a big part of the school year. Okay, putting my x-axis far enough at the bottom of the paper so that when I graph this set of points, negative 3, 11, and positive 3, 11, I can go up 11. So I'm going to start with 0, 2. 0, 2 will be on the y-axis. Now we have negative 1, 3 and positive 1, 3. Okay, then we have positive 2, 6, negative 2, 6. So let's see, this is 3, 4, 5, 6. Whoops, right here. And then we have negative 3, 11 and positive 3, 11. Let's see, this was 6. So 7, 8, 9, 10, 11. And once you start to see that symmetry, it kind of saves you a little work. Okay, let me know how you feel about the music. Probably didn't even have to say that. I'm sure you will let me know whether I ask for that or not. I'll try to get a different playlist for the next video. Okay, so that's it for 444.